Optimal material to help curb light pollution and the urban heat island effect. Light pollution, also known as photopollution or luminous pollution, is an alteration of natural light levels in the night environment produced by the introduction of artificial light. As seen in this chart, light pollution in the United States has increased every decade, and as predicted, much of the US will be flooded with excess light in the night sky by 2025. In the United States, 6% of the electricity produced is used for outdoor lighting. Of that 6%, 30% of the light is wasted as light pollution, wasting about $10.6 billion a year. Light pollution causes harmful effects to animals, leading to the deaths of migratory birds around tall lighted structures and those of hatchling sea turtles disoriented by lights on their natal beaches. The wake-sleep rhythm of humans is synchronized by the intensity and spectral composition of light. In the daytime, sunlight acts as the natural zeitgeber. At night, the human circadian clock is programmed to allow for humans to sleep. However, artificial light caused by light pollution prevents human production of melatonin, therefore disturbing natural sleep rhythms. This causes many health problems like sleep deprivation and even cancer. The human eye is sensitive to different wavelengths of light. Spectral sensitivity is the relative efficiency of detection of light as a function of the frequency or wavelength of the signal. The graph shows the relative sensitivity of the eye to different wavelengths of light. The x-axis represents the wavelength in nanometers, and the y-axis shows a normalized response. The human eye is most sensitive to light in the 500 to 600 nanometer wavelength range. Different light bulbs are relatively intense in different ranges of wavelengths of light. The chart produced by Gaston shows the relative intensities of different lights as a function of the wavelength, with wavelength representing the x-axis and the relative intensity representing the y-axis. The urban heat island effect is a phenomenon where a metropolitan area is significantly warmer than its surrounding rural areas. One of the reasons for this is the absorption of sunlight on man-made materials such as the road or sidewalk. The figure above shows the significantly higher temperatures of urban areas compared to rural areas due to human activities. When an object absorbs light, it converts that light to thermal energy and emits it back out as heat. So, because black objects absorb more light, they also emit more heat. The rate at which an object can reflect solar radiation is called its albedo. The bigger the albedo something has, the better it reflects radiation. The buildings and the pavement absorb a significant amount of light and radiation and emit it as heat, warming the city. Because more than half of the surfaces in cities are man-made, cities heat up more than rural areas where structures are less concentrated. Lee in 2013 designed a high-performance LED streetlight using micro-lens arrays. The light uses a simple but effective design. A cluster of LEDs with total internal reflection lenses is put inside a reflective box, which is covered with a micro-lens sheet. The reflective cavity recycles the light and shines the light in parallel rays, a process called collimation, so that it only goes where desired, which is only on the road. Fulci in 2011 tested different lights on the suppression of melatonin. He compared the energy and melatonin suppression of low-pressure sodium, metal halide, natural white LED, and incandescent lights relative to a high-pressure sodium light. Fulci found that low-pressure sodium light was the least harmful form of light, and natural white LED light was the most harmful form of light. Coulson and Reynolds measured the amount of solar energy reflected from various types of vegetation as a function of sun elevation in different wavelength ranges in the ultraviolet, visible, and near-infrared regions of the spectrum. The figure shows the hemispheric reflectance of green bluegrass turf at 5 different wavelengths. The sun elevation in degrees is shown on the x-axis, and the reflectance percentage is shown on the y-axis. It was concluded that there is a significant dependence of reflectance on both wavelength and elevation of the sun for all surfaces tested. The purpose of this experiment is to try to find the optimal material that can absorb the most light in the night sky to help reduce light pollution,
but can also reflect sunlight in the daytime to help reduce the urban heat island effect.
Hypothesis of this experiment is that concrete will be the best at reducing light pollution and the urban heat island effect. The experiment will be conducted by branching into two circumstances, daytime and nighttime. In the nighttime simulation, a lamp will be set up 1 meter above the surface and 4 bulbs will be used: high pressure sodium, metal halide, white LED, and compact fluorescent. They will then be shined onto 3 types of surfaces: concrete, which is used for sidewalks; asphalt, which is used for roads; and slate shingle, which is used for roofs. Using a light meter, the amount of light reflected will be measured in lumens. In the daytime simulation, sunlight will be used to shine onto the same 3 surfaces, and an infrared thermometer will be used to measure the temperature in Celsius. The data collected will be analyzed using a descriptive analysis of means plus or minus the standard deviation, and a statistical analysis using a two-way ANOVA followed by a post-hoc Scheffé test with the p-value less than 0.05. A light sensor and infrared thermometer will be obtained from Vernier. A clamp lamp, white LED, high-pressure sodium, metal halide, and compact fluorescent light will be obtained from Home Depot. Slate shingles, concrete, and asphalt will also be obtained from Home Depot.